Hey there, coders. Welcome back to another exciting episode in our Rust programming series, where we will dive deep into one of the core concepts in Rust, that is ownership and how it interacts with structs. In this video, we will explore two ways of defining structs. That is first using owned types and second by using references, with detailed explanation and real-world implication of both approaches. First, start with example number one, that is struct with owned fields. Let's start. First, define one struct with name user, parameters that is string, and email, also string. That's all. Here, the user struct consists of two fields, username and email, both of type string. The string type is an on type, meaning the data it holds is stored on the heap and is fully managed by struct instance. This ensures that the struct has fully control over the data. Now let's get started and create an instance. User equals user, username, let's say string underscore from user1, and email at the email.com. Here we create an instance of user struct using string from to convert string literal user1 string literal and email at email.com into heap allocated string object. This ensures the struct on its data and the data will live as long as the user instance exists. Now let's access them. Print ln. Here to access username field, we use dot notation. The field is owned by the user struct and can be directly used without worrying about lifetimes or borrowing issues. Here username is accessed by user.username and email is accessed by user.email. Let's run the program and see the output. Here is the output. Now, advantage of owned type. The struct has fully ownership and control of its data, simplifying lifetime management. Second, ideal for scenarios like the struct needs to maintain its data independently, such as when returning data from a function. Now, let's come to second type, that is struct with reference. Let's remove this. Create one more struct user, single quote a, username, a string, email. Here, here the user struct now uses reference for username and email fields instead of owned string. The lifetime specifier is single quote a, is introduced to ensure that the data referenced by username and email lives at least as long as the user instance. Now create variable. First variable is username equals user1 and email as email at email.com, and let user equals, sorry, Here variables username and email are string slices. That's why we used and str. And these slices are borrowed references and are not owned by the struct. Now, here we initialize the struct. The user struct borrows the value of username and email through references. The lifetime the lifetime single quote A ensures that these references remain valid for the duration of user instance. Now access these fields using println function. Access email. Similar to previous example, that is we access field using dot notation. However, these fields are references, not on data. Let's check out. Now, advantage of references. It is more memory efficient as it avoids duplicating data. Useful when the struct is temporary view into existing data rather than owning it. Now, let's see differences between them. Here are the differences. First, on data is stored data on heap and borrowed and references borrowed data no copying. Lifetime management in on data simple follow struct rule. In references requires explicit lifetime. Flexibility full control of data. Efficient for read only data. So as we talk about real world use cases, imagine building a web application where user data is stored in a database for temporary operations such as validating input or rendering templates. Using reference could be save memory and improve performance. However, if you need to pass user data between threads or store it long term, on types on type string are a safer and more flexible choice. That's all for this video. I will see you in next one. Keep building with Rust. Thank you.